Very good. Negative 20x to the negative 6th. Be careful with your negatives. And if I rewrote this back in proper algebraic form, does the negative 20 drop to the bottom?
No.
It's negative though. It's only on exponents. Okay, so negative 20 stays up over x to the 6th goes down. Does that make sense? Talk to me about questions.
Number 5.
All right, number 5. I'm going to quickly rewrite this. So, and I'm going to move the camera so it gets in. Okay, let me zoom in a little. Okay. So we have, this is just 5x to the 8th. This is 3x to the 4th. This is 8x to the 2/3, no difference. And this is 6x. Now we get into the fun stuff. What's this? X to the what? 1/5 plus 2x to the negative 1/2. Negative because it's on the bottom, and 1/2 because of the root. And then minus 0.875. All right, that's just rewriting the function. We haven't taken the derivative yet. So now we have to find the derivative.
For every single value?
For the whole thing. Are you ready?
Yeah.
Okay. Mustafa, what's the derivative of the first term?
Okay. So 8 times 5, that's 40, right?
Yes?
So 40x to the 7th?
Beautiful. All right, someone else, tell me the derivative of the next term.
Can I choose them?
12x again, 12x cubed.
Beautiful. That was gorgeous. Who else?
Elizabeth.
Elizabeth, do you have this?
I do.
Okay, I'm ready.
16/3 x to the negative 1/3.
Beautiful.
Oh, yeah.
This one, actually, of this whole problem, this one is the one that people get wrong more often than anything else.
So
Okay.
6.
What's the answer?
6.
Andrew says 6. Y'all agree?
It's 1.
He's right.
Oh!
Because the derivative of x is 1, but that's a constant multiplier, so you'd have to do 6 times that 1, right?
That's what I was thinking.
Yeah, think of it as like 6x to the 0. It's
But then I
6.
trusted my table mate and he proved me wrong.
Oh, that's-
snap.
All right, it's still good to trust your table. All right, here we go. Minus, okay, derivative of this guy. Who wants to take a chance? Don't be scared. Camille, yes.
Alright. I got 1/5 x to the negative 4.
That is perfect. Good job. Well done. All right, next one. Nobody else wants to take a shot? Be brave. Is it going to be positive or negative? Negative. What's 2 times a half?
1.
1. What's negative a half minus 1?
Negative.
Negative 3/2. See how easy that is? Minus 0. Who said that? Yes. Did you guys all hear minus 0?
Yep.
What? Are you serious? This is like a really complicated thing. Negative
But
0.875. What tells us it's 0?
Constant.
It's a constant, right? Okay, now we got to rewrite this whole thing. 40x to the 7th minus 12x cubed plus, all right, what's going to happen with this one? What's going to be on top? 16. On the bottom we have 3 times cube root of x.
This isn't on our homework.
6 is just 6. Okay, minus, what's going to be on top for this guy? 1 over 5, ooh, beautiful. 5th root of x to the 4th. Minus 1 over square root x cubed.
Bang.
Is that okay? Charlotte, how you doing? All right. All right. Charlotte, I thought of you this weekend. Do you know why? Because me and my older son watched National Treasure. You don't get the reference?
No.
Oh, really?
Isn't the
Secret
boat
Lives
called
of
the Charlotte?
Oh, okay.
The boat.
So anyways,
It's like the
the name of the boat.
like the opening scene from the movie.
Okay.
It's the most important scene. Yeah, let's just blow up a boat.
Okay, so anyway, next, we got two more quick examples and then I gotta talk to you about what differentiability means and then we're done.
Quick example.
So,
So no more number 5.
Number 5 was my favorite.
That was my favorite. Yeah, my favorite.
That's the one.
here we go.
I thought you were gonna pull me
Okay.
back in like a second.
First example, so this will be like number 6. So if f of x equals 1 over x squared, find f prime of 2. Now you know how with the general, when we use the limit definition of the derivative, there were 3 definitions. We had a general definition which gave us f prime of x, and then we had 2 alternate definitions which gave us f prime of a specific number. So the general gave us the slope finding function, the alternates gave us the slope at a specific value of x. All the derivatives you just found were general. They all had x's in the answers, they were all slope finding functions, right?
Right.
We need a specific derivative at x equals 2. There's no shortcut to get to the specific derivative. So what you have to do instead is use the shortcut to find the general derivative and then just plug the 2 in. Okay? So, what I want you guys to do is in your groups very carefully find f prime of x. Be very careful.
It's in the bottom.
We do not have a rule for 1 over x to a power. We only have a rule for x to a power. Make sure you rewrite it properly.
Yeah, it's x. X to the negative 2. Negative 2. It's just x to the negative 2.
You guys all checking with your group mates? Do you all agree?
Yeah, no, we're not. We haven't agreed.
Jacob is being difficult and probably wrong.
Again.
So I got negative 1 over 2.
We got
I got 1, negative 1 over 2
Did
times
you find the derivative?
the square root of x cubed.
I think that's a negative 2.
Go no, dude. Alright, now just look at it. Look at 2. It's 2 times negative 2. Negative 4 taken to the negative 3.
Very good. Good use of groups. All right. So if I were to rewrite this function, how would I rewrite this?
X is negative 2.
X to the negative second. So my derivative is going to be negative 2 x to the negative third. When I rewrite my derivative back, what stays on top? Negative 2 stays on top, and only the x goes to the bottom. Because this negative power is only on the x, it's not attached to the negative 2. If it was all in parentheses, it would be. But since it's just negative 2 times x to the negative third, the x is the only thing that drops to the denominator. Do you understand that?
Yeah.
Negative 2 stays up. Okay, did everyone get this?
No.
No? Are there questions?
Not anymore.
Where did the 3 come from? Okay, your power rule says you take the power and then reduce it by 1.
What's negative 2? 1.
Does that make sense?
Yeah.
Okay. Alright, so now we need f prime of 2. How am I going to find f prime of 2?
Plug it in.
Plug in the 2. Negative 2 over 2 cubed, or negative 2 eighths,
1/4. Negative 1/4.
which you could rewrite as negative 1/4. Would you have to?
Yes.
No.
No.
Okay.
You do not have to reduce fractions, ever. Okay? Well, for multiple choice, you do. But for free response, you don't. Okay. Last example, and then we have just a little bit more notes, and then we're done. So, if
No, she has to teach us about
f of x equals the cube root of x to the 5th,
So cube root of x to the 5th,
write the equation
so that's x to the 1/3.
of the line tangent to f of x at x equals 8. No calculators. So, if you have the line tangent to f of x at x equals 8, no calculators, and it's the cube root of x to the 5th, what do you think you should do first? Should you find x to the 5th?
Derivative.
Or should you find the cube root first? You gotta find the point. What two things do you need to write an equation of a line?
Point and slope.
Point and a slope. So the first thing I always find is the point, right? So the point, well, that's 8 comma f of 8, right?
Yeah.
I need the cube root of 8 to the 5th. No calculator.
Well, that's.
Do I have to do the power first and then the root, or can I do the root first and then the power?
No, it does.
I'm gonna be honest with you, I have no idea.
No, you don't need, it doesn't matter, it doesn't matter.
It doesn't matter, it's all one power. So do the root first because it keeps your numbers small, right?
Alright, so
Do the root first.
So you can just plug in
2 to
the
the 5th. 2 times 2 is 4, and then 4 times 2 is 8, then 8 times 16, and 16 times 2 is 32. We're smart.
Very good.
Wait,
Did you guys all get that?
Why don't
Did you hear this group right
No,
here?
because what's 8 to the cubic root, Mustafa? It's 2. Gosh. So
That's
it's
what I said.
So you do, yeah, you plug in an 8, you do the cube root first. What's the cube root of 8?
2.
2.
2. What's 2 to the 5th?
32.
32. There's your point.
So we didn't have to do all of that on the left.
Well, no, you need something else to write the equation.
Be the
What
slope.
What else do you need?
The slope.
Slope.
So we have to do that.
Yeah. So what gives you slope of a tangent?
derivative.
The derivative. So everyone, you're going to have to find f prime.
Okay. Alright. We have to rewrite it first. So 2 to the x to the 5th, 5 over 2. Right? Or 5 over 5.
Yeah, negative 5.
Why negative?
Oh, no,
No, it's just x to the 5 over 3.
That's
So
5
then it's,
Are you sure now?
yeah, 5 over
Positive now?
over, what's that minus? That'd be 6 minus 3, that's 1 third. Negative. Oh, that's, oh, you're right, 3 over 3. So yeah, you're right, 2/3.
What's the cube
3
root
over
of
3 is 1.
16.
So mine, so 2/3, you're right. So it's just
Find the cube root.
it's 5
So
5 thirds,
it's gonna be 2
5
squared
raised to
more.
the 2/3,
20 thirds. 20 thirds.
right?
So 5 thirds.
So then it's y minus 32 is 20 x
So if you
squared.
do 5 thirds,
Yeah, no, wait.
cube root of x squared.
Yeah.
X squared.
Yeah, I got that. I got the
X
What are you
squared.
talking about? I do. I live in
X squared is 64. Minus the cube root of 54.
Alright, let's do this. Now let's do this.
Oh, wait, yeah, you just plug it in.
So now you know 4 times 5.
That's a 2. Go. I can't read your handwriting, you know why? 'Cause it's in the trap.
All right.
Y minus 32.
How do I rewrite this function as x to a power?
Y minus 32.
X to the 5/3. So what's the derivative?
5/3 x to the 2.
5/3 x to the 2/3. To rewrite this back so that I can plug a number in and actually get an answer, I have to rewrite this as 5/3 times the what?
Cubic root of x squared.
Cube root of x squared. Or you could write 5 times that all over 3. It's the same thing. Alright, so, but I don't want that. If and every once in a while I have students who tell me the equation of the tangent line would be y minus 32 equals 5/3 times the cube root of x squared times x minus 8. Now let me ask you something. Is this an equation of a line?
No, because there's
You don't
an
have a
x
slope.
and slope.
Exactly.
So
Very
close.
good. And a linear equation has what kind of a slope?
A number slope.
Constant slope, right? So this is not linear. Don't give me this as an equation of a line.
Okay.
Okay? This is your slope finding function. It's not the slope when x is 8. So instead, how are we going to find the slope when x is 8? Plug the 8 into the derivative. So we have 5/3 times the cube root of 8 squared.
We already
What should I do first?
Cube
Cube root. So I have 5/3 times the cube root of 8 is
2.
squared is 4.
4.
So So this is just 20/3. And that's my slope.
I knew that.
So y minus 32.
Does that make sense? Yes? Lucas, I
Yeah.
Good, okay.
Gosh, that was so easy.
All right, we have 3 conditions for differentiability. By the way, let's write down a quick word,
So you know how to spell it?
just so that you know this word. Okay. Oh, I'm zooming in. Okay.
This looks awful short.
The process of finding a derivative is not called deriving. It's called differentiation.
Why?
Because when you derive something, it means you're kind of coming up with it from scratch. Like we're gonna derive the formula, right? It means you're creating or producing the formula. But to differentiate means to find the derivative. So if we say I'm gonna derive this function, that means you're creating the function. But if we wanna find the derivative, you say you're differentiating the
We should
function.
just call the derivative like differentiative.
The differential, actually differential means something else. All these words are used, I know. So we can't. All right, so here's the thing. You know how there are 3 conditions for a limit to exist? And there are 3 conditions for a function to be continuous? There are 3 conditions for f of x to be differentiable at x equals some constant. So there are 3 conditions for differentiability, for the derivative to exist. Condition number 1, I don't know if you guys remember, but you had 3 conditions for a limit to exist. You had the first condition for a function to be continuous was that the limit had to exist, right? Was one of those 3 conditions. Then you had 3 conditions for continuity. Now we want to know the 3 conditions for differentiability. The first condition is going
Has
to
to be
be
continuous.
that f of x must be continuous at that point.
So there
Function
must-
has to be continuous for the derivative to exist. Each one kind of uses the last.
God bless you.
The second condition in words is there can be no sharp turns at that point. Let's just say turn at x equals c. No sharp turn. Now, there's one function everyone always automatically thinks of that has a sharp turn. Absolute value of x at the vertex is not differentiable. Because if I were to draw absolute value of x and I said, hey, what's the slope at that point? What would you say?
Not possible.
And could I draw a line tangent that shares the same slope as the function at that point?
Yeah, it's 0. No.
There is no slope. Because what happens is you've got this slope coming into that point and this slope going out of that point. You have 2 different slopes feeding that same point. So because the derivative from the left doesn't match the derivative from the right, the derivative at that point does not exist. Okay? So in other words, the derivative from the left must equal the derivative from the right. Slope going in has to match the slope coming out. Otherwise you get a sharp turn. Alright, and then the last one, no vertical tangent at x equals c. So a function obviously cannot be vertical because it would fail the vertical line test. But a tangent line can be vertical. If you have a function that does this kind of thing, comes along and then goes on like that, where you have this one little dot right here, and the tangent there goes vertical. What is the slope of a vertical line?
Infinity.
Okay, or in other words, undefined, right? A vertical line, they teach you when you're young that a vertical line has no slope, right? Technically, it has a slope that's approaches infinity, or in other words, it's an undefined slope. The other way to think of it is if you think change in y over change in x, you always have a change in y, but there is no change in x, so you're dividing by 0, right? So what ends up happening is when you have a vertical tangent, there is no slope, it's undefined, so of course, since the derivative is the slope of the tangent, the derivative would be undefined, right? Okay, so those are your 3 conditions for a function to be differentiable at x equals c. And those are the last of all 3 conditions. We're done with all of the 3 conditions. Okay? So, homework tonight is section 2.2a.